When we're going to write the equations of the conic sections, it's first important to identify which conic section we're dealing with. This one is going to be an ellipse, which is going to take a fraction plus a fraction equal to 1. In the numerator, my fraction is going to be the x's being squared and the y's being squared. First, what goes inside of each of those parentheses depends on where the center is. And this center is at the point 2, -1. So with the x is going to go the opposite of 2. And with the y is going to go the opposite of -1. The denominators of each of these fractions are going to be the distances squared in each of the directions. So from the center in the x direction to get to the edge, we only take one step. So the denominator is going to be 1 squared, or 1. In the y direction, whether we go up or down, this is 3 units. So when we square that, we'll get 9, and the denominator is 9. Therefore, this is going to be the equation of this conic section. But how about a parabola with a vertex at 17, 21, and a focus at 17, 17? Well, since we know that it's a parabola, that's going to be 4c times either x or y is equal to the other one being squared. But I don't even really know what's going to come first, the x's or the y's. So it's a good idea to come up with at least a sketch of what's going on. And for this problem, it says the vertex is at 17, call that 17, and then up 21. So that's where the vertex is going to be. The focus, it says, is at 17, 17. So the focus is going to be down below, meaning the parabola opens downward like this. Since it's going to open vertically, that's going to mean for our equation that y is going to come first, and it's the x's that are going to get squared. What goes along with the x's and y's comes from the vertices. And since we're dealing with y first, the y coordinate is 21, so this will be y minus 21. The x coordinate is 17, so we'll do x minus 17. The last piece of information we need is the distance from the vertex to the focus so we can identify what that coefficient is going to be. Well, when we look at our graph, we can see that the distance from the vertex to the focus is going from 21 down to 17. So that distance c is just going to be 4. But since it's going down, c is going to be have the value of -4. That means that 4c is going to be 4 times -4, or -16. So the coefficient that's out in front is -16, and this is the equation of the parabola. A circle centered at the origin passing through the point -9, 0. So if we think about what it's going to look like first, it's got a center at the origin, and we're going to pass through -9, 0. Well, since it's a circle, we're going to go the same distance out in all directions. And since we went back 9, that means we'll go forward 9 and up 9 and down 9 in order to get our circle. That means the radius is 9. So we'll go ahead and grab the form for the equation of the circle, which is the x's squared plus the y's squared equal to the radius squared. We just said the radius is 9, so when we square that, we'll get 81. The x's and y come from the center, but that center is at the origin at 0, 0, so it'll be x minus 0 and y minus 0. And when we clean that up, we'll just say x squared plus y squared is equal to 81. And there's our equation. Now we have to write the conic with a focus at 2, 4 and a directrix of x equals -2. In this problem, it doesn't even tell us which conic section we're dealing with. So we should sketch it out to maybe get an idea of what it looks like. Well, this thing has a focus at 2, 4. And the directrix is at x equals -2, so that's a line that crosses the x-axis at -2. Well, the only conic that has a focus and a directrix is a parabola, so that's what we're looking at. And we need to know where the vertex is. Well, the vertex is going to be halfway in between the focus and the directrix, so that'll obviously be right on the y-axis, right there, and opening sideways. So we do have a parabola, which is going to be 4c It's opening sideways, so x will come first, and then it'll be y that's being squared. The coefficients that go with the x and the y are going to come from the coordinates of our vertex. And this vertex is at the point 0, positive 4. So it'll be x minus 0 and y minus 4. The last thing we got to figure out is that distance from the vertex to the focus. That distance c is just 2 units. It's 2 units to the right, so that 2 is going to stay positive, making 4c equal to 8. So the coefficient out in front is 8. We can clean that up just a little bit and rewrite it as 8x equal to y minus 4 squared. One last conic, and that's one with the center at -5, -12, opening horizontally with asymptotes at y plus 11 is equal to plus or minus 3/4 x plus 5. All right, so a lot of information there, and it still didn't tell us which kind of conic section we're dealing with. So we should probably sketch it out. And we have a center at -5, -11. It says it opens horizontally. That means that it's either going to be a parabola or a hyperbola. But this one has asymptotes, so that means that it has to be hyperbola. The slope from the center is going to be plus or minus 3/4. So if we went up 3 and over 4, that would give us one asymptote. And the other asymptote would be down 3 over 4. So looking like this. And of course it opens horizontally, so each branch is going to be over here. Now this picture does help us out quite a bit. First of all, like we said, we know that it is a hyperbola, so it's something squared minus something squared is equal to 1. Since it's opening horizontally, that means that the x is going to come first and the y will come second. Finding out what goes with the x and y, that comes from our center, which we said was at -5, -11. So with x, we're going to subtract -5, or x plus 5, and then y minus -11, or y plus 11. Now we have to think about that box. So the box, it kind of, if I just rough sketch it in here, it has the diagonals of our asymptotes in there. Now this one looks like it crosses, touches the y-axis, but that might not be the case. But let's go back to the slope. Our slope said that we had a rise of 3, that means this distance is 3, and a run of 4. So the distance from the center to the vertex, that is going to be 4. Using these two values, we went 4 in the x direction, so the denominator is going to be 4 squared, or 16. And we went 3 in the y direction, so the denominator of the y is going to be 3 squared, or 9. And there's the equation of the hyperbola.